So we'll now continue our discussion on applications of the standard normal distribution curve. We're going to begin with an example where we're going to review the concepts that we've been working on in this chapter. So our example says, the average teacher salary in New Jersey is $52,174. So again, I'm going to begin by writing down what I have. I have the mean, 52,174. Suppose that the distribution is normal with standard deviation equal to 7,500. What is the probability that a randomly selected teacher makes less than 50,000? Now, this problem is nothing new for us. We're simply reviewing the concept before we move forward. Okay, so we know that we have a formula that says that we can calculate a z-score by taking the value minus the mean and dividing by the standard deviation. So I know that the first thing that I need to do is use that formula to convert the 50,000 to a z-score. So I'm going to do that. I'm going to plug in the 50,000 for the value. Remember that the number that you are trying to convert always goes first in the formula. I'm going to subtract off the mean. So I'm subtracting 52,174. And I'm going to divide by the standard deviation. So now I'm going to calculate that z-score. And round it to 2 decimal places. So I'm going to get negative 0.29. The next step is to draw our curve. And mark off the negative 0.29. So I know that that's going to be somewhere on the left. And then decide how we want to shade. So our problem asks us to do less than 50,000. So remember, your 50,000 is your negative 0.29. We want to go less than that. So we're going to be shading in the left tail of this curve. So we'll now go to our table and we'll look up 0.29. So the z-score that goes with, the area that goes with a z-score of 0.29 is going to be 0.1141. Remember that that is the area from 0 to the number that you look up. So the area of the section that is not shaded. And we've talked about the fact that if you mark area on a section of the curve that is not shaded, that should be subtracted. So I know that I'm going to be subtracting off the 0.1141. Now, what am I going to subtract it from? I don't have any other numbers to subtract it from, so it would make sense to subtract it from the 0.5. 0.5 being the entire area on the left-hand side. And so that will give me an answer of 0.3859. Now again, this is nothing new, so we're simply reviewing that concept and making sure that we remember how to do the problems. Okay, so now we're going to look at a similar problem with a slightly different question. Okay, it still says the average teacher salary in New Jersey is $52,174. Suppose that the distribution is normal with standard deviation equal to 7,500. Okay, now this is the part that's different. It says that we are now going to sample 100 teachers. We're going to look at their salaries and we want to know, is the mean of those salaries less than 50,000? Okay, now I'm going to go back to the previous problem for just a second, and I want you to notice something. In the previous problem, the question said that we are looking for the probability of a randomly selected teacher. This is one teacher that we're dealing with. But in this problem, we are talking about a sample of 100 teachers. So when we make that change, we have to change the formula that we're using. So again, I'm going to go back to the previous one. If we have a problem where we have one person or thing selected, then this is the formula that we use. If, on the other hand, we have a problem where we're dealing with a sample, we have a slightly different formula. Okay, so I'm going to write the formula up here. It starts out the same way. So it's still value minus mean on the top. It still has the standard deviation on the bottom. So that part is exactly the same as the other formula. The difference is that we're going to put in divided by the square root of n. Now remember that n, anytime we see n in a formula in our class, n is the number of values that we're dealing with. So the number in the sample is the n. Okay, so if we have a sample, this is the formula that we're going to use. So as you start working problems from this point on, you need to make that note early on. If you have one, I'm going to use this formula. If I have more than one and they're talking about a sample, then I'm going to be using this version of the formula. Now, nothing else changes in how you work the problem. So this is really a very slight change in the process. All right, so let's go ahead and see if we can get this thing set up. All right, so I know, I'm going to write my information down again. I know that the mean is 52,174. I know the standard deviation is 7,500. I know that my sample size is 100. We sampled 100 teachers. And the question says, find the probability that the mean of the sample is less than 50,000. Okay? So our process works exactly the same way. We're going to plug these numbers into our formula. Remember that the number that we're trying to convert, the 50,000, is going to go first. We're going to subtract off the mean. So we're going to be subtracting off the 52,174. We're going to divide by the standard deviation. And then we're going to do divided by the square root of the n value. Okay, now you need to try this on your calculator and make sure that you can plug this in and get the correct answer. My recommendation to you is that you put it in all at once because you need to be very specific with the z-score. If you're off even just a little bit, you're going to end up looking up the wrong area in the table. So we have to be precise here. You need a parenthesis around the top part, and you need a parenthesis around the bottom part. Okay, so I would like for you to go ahead, grab your calculators, and try that. Okay, and let's make sure that you are able to type this thing in. Okay, if you did it correctly, you should get negative 2.0 898, so negative 2.90. Okay, so I'm going to, real quick, write down exactly how it looks in my calculator, just so you can make sure that you have in case you had any problems. All right, so in my calculator screen, I opened a parenthesis, and then I typed in the 50,000 minus the 52,174, and then I closed the parenthesis. And then I pressed the divided by key, and I opened another parenthesis. And then I did the 7,500, and then I did divided by. 99% of the problems that I have students have with this calculation is that they forget this divided by. So remember that that's there, and then enter in your square root. Okay, now technically you need to close the parenthesis here, but realize that it doesn't really matter on the end if you have that parenthesis situation correct or not. So in actuality, you could just hit enter right now and it should work for you. But again, technically you would want to close that parenthesis off at the end. Okay? Like anything else, if you are trying this at home and you're not able to get the correct answer out of your calculator, please email me and let me know. You could send me a screenshot of what your calculator screen looks like, and then I could help you see maybe what you're doing wrong in putting it in. Okay? All right, so once that's in there, we get the negative 2.90, then we proceed with the problem just like we've been doing. Okay? So that means that we draw our curve. We mark off negative 2.90, which is going to be somewhere on the left. We shade less than that, which means we're going to be shading in the tail. And then we go to our table. So we go to our table, we look up 2.90. We get 49.81. Remember that when you look up something in the table, you are looking up between 0 and the number that you looked up. Okay, so now again, I'm noting as I look at this that I have written the 49.81 in a section that is not shaded. So I know that it's going to get subtracted off. What am I going to subtract it off from? There is no other number, so I'm going to subtract from 0.5. Okay, so 0.5 is the area of the left-hand side. So we'll end up with 0.0019. And that's going to be my final answer.